How's everyone doing? Happy Wednesday. Hope y'all had a good week. I just realized something I didn't do, which is screen share my phone, so let me do that real quick. So I can show y'all what we're gonna do today. Hey never come. Sorry, like totally choked on my spit there. Alright, let me show y'all what we are doing today. I'm excited. I kind of threw this idea out there to see if people would be interested on Twitter, and tons of people were interested, so we're going to do it. We're going to go over how to implement the MVI architecture pattern for Android. This will be probably kind of lengthy, but we'll try our best. If you can't stick through it all, it'll be on Twitch. It'll be uploaded to YouTube after. Also, I played around with some stream settings because some people were complaining that the resolution got lost on YouTube, and it sounds like, from my understanding, that it's not quite that the resolution gets lost going to YouTube, but I'm not streaming at the resolution I thought I was. So let me know if this appears to be any more crisp than it usually does. I don't know if that will be the case, but hopefully it is. Hopefully, I still gotta add that. Hopefully when it's on YouTube it will look a little better. This stream will anyways, but we'll find out. So all I have in this sort of sample app so far that I want to show you guys is just a couple of inputs and a sign-in button. And right now the email one, like, you can type in whatever. There's no like validation on these or anything yet. They're just some text inputs, and then if you click the button, I have this like stubbed profile fragment. And I actually think I don't even have, my back navigation is broken and it just closes the app. But that's all I added beforehand. I always like to start these streams by going over any code that I wrote before we get started, just so everyone else is on the same page. I can show you what that looks like real quick. I actually left compose out of it for this week's stream, so all of that code is actually inside an XML file. It is just a constraint layout with a couple of text inputs and a button. If anyone wants me to go through the XML, I can, but I'm going to kind of take for granted that y'all might be familiar with XML. It's also not really necessary for the MVI conversation, but if we look at the login fragment, there's some stub code here, like this ancient technology. Yeah, so some stub code here, like getting a reference to a view model, using view model providers, inflating the view. And then I have that stub, like when we click the sign-in button, we navigate to profile, which we're actually going to change how that works as we get going. The login ViewModel class, it's actually completely empty. We're going to sort this all out today. But yeah, that's what we're starting with. The main activity is just showing the login fragment and has a method to navigate to the profile fragment. I even have a little comment in here. I actually don't think that the rendered comments show up well for y'all. But this even says that like, oh, I meant to put this here. Probably isn't like the best practice here to like have this method inside your activity, but I just kept things as like a contrived example so we could focus on the MVI architecture pattern part of all of this. But yeah, since that's going to be a little bit of a heavy conversation, I figured I'm just going to dive right into it. If you have questions before you get started, let me know. Maybe I will set up while we're here real quick, I should have done this ahead of time. Maybe I'll set up a question link on this one, because I expect this to be one where people might have a lot of questions. So let me do that real quick. That should only take me a second, I hope. New slide. And we'll do stream. Okay, so nice. So if any of you don't want to post your questions in the chat, feel free to use that anonymous question link. I will have this pinned so I can view that. I will also go and edit the command real quick so that if anyone needs it, they can reference it. Okay, so if anyone needs that again, you can do exclamation point slide u. So you're still only getting 720p. That's so weird. I thought that I had fixed that in my settings. Video. Oh, weird. Let me try this. 20 by 1080. I'm gonna try it. I hope that it doesn't like screw up my things. Oh, 720 is higher than what it used to be? Interesting. I tried updating it to the 1080, but I don't know if it kicks in automatically or not. But we'll just have to roll with it. Question in there about fragment manager. Yeah, navigation component is definitely better. I left it out of this sample app because I didn't take the time to implement it, but just wanted to show off sort of the MVI stuff that we're going to look at next. So now that I have done some of that setup already, let's start by going over like what MVI as an architecture pattern means. All right, well, hopefully the resolution works out. So MVI is like I don't know how common it is to be used by developers, but it's an architecture pattern that comes up a lot, and a lot of people are really like diehard about it. And I think it brings up a lot of really good things, but something that always gets lost in the architecture pattern conversation is we throw around these confusing acronyms and confusing buzzwords, and people who don't really know architecture patterns or understand why we need them, like the whole conversation just gets really confusing for a lot of people. So I like to take a step back, sort of like all the way to the beginning, and explain like what an architecture pattern is, why we need them, and what's special about MVI specifically. So I'm not going to talk about all of that, but I should have pulled up the YouTube video. We did do a stream a while ago on building an app with MVVM and Compose, Model View, ViewModel. And I can pull that up real quick, actually, just so I should be able to share it with you guys. But this pattern is actually going to build on top of that a little bit. Let me just find this. So if anyone is curious, you can follow up on this. And I will make sure. You're the best, Prince. I couldn't beat you to it. I will make sure that if you're watching this on YouTube, watching this one on YouTube, I will make sure to link to the previous one. But here is a little diagram of sort of what we got out of that stream. So architecture patterns, to go back, the reason we need architecture patterns, if this is the first time you're watching something related to architecture patterns, the reason we need them starts with this basic idea, right, that you can't put all of your code in one file. And I think implicitly a lot of us know this, and no one really tries to do that. But that's like the core concept that gets lost in a lot of these confusing conversations. Is our base point is that we can't put everything in one file, so we know we need to split responsibilities. And how we decide to split responsibilities into what files and what those files are responsible for doing, that's what defines an architecture pattern. So all of these confusing acronyms, MVP, MVC, MVI, MVWTF, those are all just slightly different ways of arranging our code. And each one sort of serves their own special purpose. And one that a lot of people land on is Model View, ViewModel. And I think that's because it's really good for, to throw an arbitrarily high number, like 95% of use cases. And this is a diagram of what that looks like, right? So the different letters, Model View, ViewModel, each one refers to one of like three components. Where you have, let's start with M. So you have your model layer, which is anything responsible for returning data. So this repository represents a data source. It could be a database, it could be a remote network API, it could be your file system, anything. Some way to say here's where data comes from. You have your view, which will be your activity or fragment, and its sole responsibility is being able to display data. And then the view interacts with something called a view model, which is something that sort of controls the UI logic. So that happens through either the view will have some event happen, like a click or text change, and what it will do is it will tell the view model, hey, this thing happened. So your fragment doesn't need to know what happens when a button clicks, right? The view will say a button was clicked, and then the view model is the thing controlling everything. That's what will decide what to do when a button is clicked. And based on all that, it exposes this view state, and that will be what the view renders. And this is a dashed line because this isn't like a direct reference. Usually what will happen is the view model will expose something through like a state flow. Hey, the last Basilope, thank you for the follow. It will expose something through like a state flow or live data or RxJava, whatever it may be. And then this other connection, so the view model is the one that talks to your data layer. But what that leaves out is sort of a lot of questions about what happens inside of here. If you have a lot of network calls, or maybe you have like some analytics tracking, and you can just have a lot going on here, and state management can become really difficult. And I think that's sort of one of the biggest benefits of MVI, is it's a way to get more clear and predictable state management in a way that a view model doesn't. And I don't have code to show you to really demonstrate this, but one example I used in a talk I gave on this before is, let's say you have a view model and you have like these 3 functions in it that can manipulate state. You have one that shows a loading state, one to say show success, and one to say show error. And if you have each of these functions, you could code it the wrong way to where they get called in any random order, when it's not like show loading being called first like you would expect. And it's hard to relate those individual methods to some specific action or intent. And that's what the acronym MVI stands for. It's Model View Intent. And unlike these other patterns where that third letter refers to like an individual component, it's rather to capture the idea that we have the intent of doing something, and whatever that intent we are making affects our state. I hope I'm sort of explaining this well. I'm trying to talk through it before I draw it up, but if that makes sense, now we can start to draw it up. So it also follows a pattern of a popular library used in web frameworks called React. And I'll show you a diagram of that, but then we're going to move it over to our other diagram. But the way that typically works, here's how we should think about the state management that we're working towards. So we have a view that emits some actions. Some text changed, a button was clicked, this is an action that happened. And that goes into our dispatcher. And what will happen then is we need to go through something called, I should actually back up. We have a state. This is actually our starting point. We always have some state that represents like what our screen looks like at any given time. And even when you first load, and even when nothing is there, like that's our state that we are working with. So then what happens every time an action happens is we take that action and we take our given state, and based on those 2 things, we need to produce a new state. And all of that happens inside something called a store. And the purpose of the store is really to just be like our state container, to hold in all of that logic. But that concept, this concept of the reducer, is that key sort of like predictable state container or predictable state management that I said we wanted, right? We have an action that occurred, we have some state, and we get a new state. And this really gives us a good finite state machine, clear and predictable state management. When we actually write the code, it might become more clear to some of you. Others might see that idea already. So what I'm going to do is I'm going to take this idea, I'm going to push it over to our other diagram just to talk through it, and then I'm going to write some code. But I think it's really good to sort of see the diagram before we write the code, so you'll have some idea of what's going on here. So, and then the other nice thing is this doesn't necessarily have to be used in sort of an MVVM architecture. If your app is using like Model View Presenter, I won't go into it, but you can use this sort of Redux pattern with that as well. But let's, where are we going to start here? Let's start by drawing up another square for our store. So we'll call this a store. And again, this is just a naming convention, but this is our state container. Can I move the text on this? This is my first time playing around with this. I can align it to the bottom. That's close enough with this tool here. But so what's going to happen then is inside of this, we are going to have something called a reducer. And I'm going to draw this over to the side and then move it. And we have sort of 2 inputs that come into this. Let me draw these lines here. So from our store into our reducer, we have 2 inputs. The first one is our current state. Let me shift this over and expand these. We have our current state and some action. What we are in now and some action that occurred. What's going to happen is out of this, we are going to, not what I want, return some new state. And that's going to go back into our store. Okay, and then all that our store is going to do is then do a similar thing. We're going to just expose that view state from the store. And this can also be, should be like a dashed line. It's not going to be a direct reference. And then what we'll do is the view model as well is going to be the one responsible for passing an action off to. This didn't dash. Oh, it did, it's just short. So let's do that so you can see it. Pass an action off to the store. Does this make sense so far? Is this like a decent start? What's different here than just managing the state inside of our view model is the idea is this. Like, I can't sell this enough. This idea that we have some state and action coming in and we get a state out makes it just very clear what's happening. There's a clear intent with each state change. And then this container is just a way of keeping track of all that and passing it through. So I'm just going to check Slido to see if anyone, no other questions yet. So yes, and Matt brings up a good point that as you do this, all state should be immutable. So what we can do is our state can be like a Kotlin data class, and anytime our reducer changes it, we would just use a sort of like the copy method on a data class. So nothing can be mutated along the way. There's portions of this that that I didn't include because I don't really understand this concept very deeply, but there becomes a question of like, how do we handle side effects? Things that we want to do that don't necessarily belong in the reducer. Let's say you want to log every time an action happens. So that can be done through something called like a middleware, which follows the same pattern of the reducer, except I don't think it's intended to change the state. Let me see if I can find a diagram of this. Yeah, so here's a diagram that kind of explains, whoops, I should have opened up. What I was describing is the way a middleware would work is it would just take in the action, it would perform some actions, and then you would go into a reducer that is actually going to change your state. We can look at this towards the end of the stream. I think that I'm going to leave it out for now. But bear with me, we can definitely come back to it. Because I think when it comes to making like a network call, we might want to do something like that. Yeah, but we will go without it for now. So this is sort of the high level diagram of what we are, trying to get to. And I hope that this made sense to some of y'all, Maybe it will really hammer it in when we look at some code. But it's important to understand all of these pieces, because the first bit of code that we're going to write is to write some interfaces to define how all of these components work together. And then we can hook them all up. So if there's no questions on this diagram and on the core concept, let's dive into some code. So I'm going to start by going over specifically the Redux stuff that we just talked about before I talk about how it hooks into our app. So there are some libraries out there that have what I'm about to write for you. I don't know any of them well enough to put my recommendation behind any of them, but if you don't want to write all this boilerplate in your own project, you don't have to. So let's start by talking about a state. Good question here. In the context of MVI, a reducer could be part of the model concept. I don't think so, because the model really typically in architecture patterns just refers to your data source. And so that's all it should be responsible for, is requesting and displaying data. One way they might be related is to think about, how do I put this? There can be actions associated with your model requests. So something that might happen is if the view model is requesting data, and this actually might get, just made me realize I could move this. But one way to think about it is if your view model is requesting data, there can be an action associated with that, like fetching profile. And then that would manipulate your state. Maybe it wants to then show a loading indicator. And when that's done, we would send another action into our reducer that says, data loaded. And then we hide that progress bar. And that brings up a good point that when we get to that, I might change this. Where this arrow comes from, because I've seen examples where the way a network request would work is that it would send some action, say load profile, into the store. And then that action, instead of being handled by the reducer, would be handled by like a networking middleware. And the networking middleware would make the request, and then when the request is done, actually pass the information into the reducer. And maybe we'll rework that, but I think I'm getting a little ahead of myself on a little more complicated use case with MVI, but we can definitely come back to that. I appreciate that question. So with the Android code, one way to do this is you can actually create some empty interfaces for each of, for your state and for your action components, right? Because state can vary from screen to screen, but we know that it's something that every screen will have, and it's something that needs to be manipulated by our reducer. So really the only benefit of this interface is kind of getting like type safety when we actually implement a reducer, so that I have to pass in something that is a state interface, but that state interface could really be anything. So we can document this and just say, while this interface is empty, it is used to clearly define any class that is representative of a view state for a given screen. So that's what our state interface is going to do. And similarly, we will have an action. And this can also be an empty interface, but we can say, while this interface is empty, it is used to clearly define any action or intent that should be taken, or that was taken on a given screen. So now that we have these two classes, we can actually begin to build like a reducer. And this reducer interface just has one method that we talked about earlier, which is reduce. Which would be, okay, we're given some current state, which will be our state interface, and some action, and this returns a new state. So let's put that documentation here. Given a current state and some action that the user took, produce a new state. And let's add some comments in here just for the people who are following along. So this will give us clear and predictable state management that ensures each state is associated with some specific user intent or action. So I debated, oh, you can't see all of that text because of my photo. There, hope that helps. Given a current state and some action that the user took, produce a new state. This will give us clear and predictable state management that ensures each state is associated with some specific user intent. I debated to whether or not I wanted to write it a different way, which is that if you think about the scaling of an application, state is an empty interface, but maybe we don't want a reducer that can work everywhere. Maybe we want a way to scope a reducer to a specific kind of state or a specific kind of action, like a login screen. So one way you can do that is with generics. So we could give our reducer two generic types, one that is our state and one that is a certain type of action. And so then we can create like a login view state and a login action, and then have those be specific to our reducer. So instead of state and action down here, we can reference those generic types. And I think this is personal preference, but I think it's a good idea, because if I have a reducer for managing the login state, I don't necessarily want to be able to dispatch like profile loaded action onto the login reducer. So this is just a way that you could use to limit them. And if you don't want to, you can just pass in like the base class at the call site. Maybe we'll look at an example. So from that, let's build a store class. This will be our last part of the MVI components. Okay, so let's talk about what a store is. So a store is our state container for a given screen. It will need two things when it's created. The first one is we can give it an initial state, and then we can give it a reducer. And I'll just put generic things for now. Hi, my friendly courier. Hope you're doing well. And let's finish up this documentation real quick. So this is the initial state of the screen when it is first created. And then the reducer will be a system for taking in the current state and a new action and outputting the updated state. So similarly to like our reducer example, we could have our store also be generic to any specific state or action type, and then we can use those here, which will be nice. Yeah, I think it is similar to like the block pattern that you see in Flutter. And so there's reasons that it's successful, right? To be able to get that sort of clear and predictable state management is really nice. And we're really close to looking at how we can use that in our application. But let's talk about what a store needs. So your store can expose a state in a number of different ways. I've seen libraries that do this with like a callback, but I think what I'm going to use for this project is a state flow. So I actually don't know if I do have the dependency in here. So we can create a mutable state flow that starts with our initial state. And then we want to expose a regular state flow that's not mutable. And that will just name shadow the underscore version. Yeah. And the only thing our store needs is a dispatch method that will be given some action and fire it off. So this is where we could first run it through some middleware that we talked about in the beginning. But again, leaving those out for now, all we're going to do is run that state through like our reducer. So we can say like our new state is going to be, well, let's get our current state. I'll write this out just to be clear. Our current state is underscore state.value. Our new state is going to be reducer dot, this needs to be private. Reduce our current state and the action. And then we can say state.value is equal to our new state. So this is how our store works. These are nice. They're just a handful of lines. You actually won't need to write another one of these, most likely. But it's just the state container. It keeps your state. It chucks off the actions to the reducer, which figures out how the state should change, and then updates your state flow. Any questions on the 4 classes that we just wrote? Anything you want me to go over again? If not, we can look at implementing the login portions of this, but I just want to make sure that the core MVI core components that we just went over are good. What's state used for? Good question. So the state, let me see if I can go to that. So the state is going to be just any data class that defines the view for a given screen. And that's actually my next step. So let me show you a concrete version of that. Let's go to our login folder and let's create a class called login view state. So typically these are data classes. And again, it's just a way of describing everything that could be on your screen, or every view component of the screen. What does it look like? So for our login screen, which just had an email input, a password input, those would be 2 pieces of information. So the email would be a string, the password would be a string. I'm thinking ahead at other parts of this. One property that could be here is like whether or not we should show a progress bar. Like when we click the login button and we're making the login request, we might want to show that information. So we could have a boolean for show progress bar. And I'll actually, I'll give these some default values so we don't have to do that elsewhere. That's a personal preference. Some people actually don't like default values when they're creating their state, so they're forced to be explicit. But I'll use default values for this example. And then Matt gave me this idea. We could work around if the user tries to log in with invalid information. So we could have additional strings like an email error. And, whoa, that is not how you spell it. And I'll make this nullable. So we can say if it's null, there is no error. But if this has a value, then there's some error message that we need to show. Ah, great. Matt caught that. I need to extend my empty state interface so that I can use this. Whoops, this is password error. And we'll add a quick comment for the other people and say this is an implementation of state that describes the configuration of the login screen at a given time. Okay, so I hope that actually cleared up what a state represents, and I hope seeing these property names helps you understand how the state relates to the UI. Let me know if you have any questions on creating the login state. But the next thing we need to talk about before we can build our login reducer, which is like the meat of this whole stream, before we can build that, we need actions that can happen on the login screen. And this is there's a couple different ways that we can do this. I'm going to show you something I like. Might be controversial. I don't think so, but it might be. Which is that when I like to group actions to like a specific screen like this, I'm going to make it a sealed class that extends our action interface. The only reason people might not like that is because if you have a lot of actions, then you have these really cluttered sealed actions. Semantically, should a state class be domain-driven or presentation-driven, considering a clean architecture as well? Can you clarify what you might mean by domain-driven? Maybe you mean like sometimes I've seen people do like an enum or sealed class where instead of your state being like this, a data class that is all these properties, I've seen it be like an enum where your state is loading or loaded or error. Is that what you mean? The difference between something like this and doing a sort of like enum that is more like domain logic? I want to make sure that's what you mean before I answer that. Good old Twitch latency. I have to figure out if there's a way to shorten that. But if that is your question, one of the reasons that I come to prefer this is because I always find like slightly nuanced cases of using that other approach where you have like a sealed class and like the 3 states you expect to be in, because you might run into a nuanced case. Here we go. Okay. Yeah, okay, good. I'm glad I asked. So, yeah, so I think both can work. And this, I'll admit, is sort of a personal preference and experience thing, is I've run into some nuanced issues of trying to use like an enum class or like a sealed class for this, because let's talk about a progress bar. You brought up a really good point. On a lot of screens, I have a progress bar that shows in the beginning, and I've loaded some data, and the progress bar goes away. But I've built a couple screens where that progress bar can come back. Let's say I'm loading new data, or I'm taking a user action, and I want to show a progress bar on top of the data that's already there. Like an example, an app has, it's an e-commerce application. You show a loading indicator when you're loading all of the items, and then when the user adds some to cart and clicks checkout, you show the loader again, but you also want the items behind. And if you're using like a sealed class, that becomes a little confusing, right? Like, well, do I so I show it when I'm loading, but I can also show it when I'm in a loaded state. And maybe your question's not so much about like should you or should you not use a sealed class, but one of the reasons I like doing it this way is because I don't really have to think about that. Like this is the state, and whatever powers it is going to be handled elsewhere. Versus like if your state class itself is domain driven, it's hard to separate those two concepts. I don't know if I'm explaining it well, but I think that was like the key point, is like your state class should just be that. It should just say, here is what the UI looks like. And anything that maps why the UI should look like that is a separate responsibility. And that's what our reducer is going to do, that we're going to see in a couple files here. So I definitely think that, depending on the size of the project, I don't think that having like a domain-driven approach is bad, but that's an example, like that's one reason I wouldn't use it. Because you can say whatever you want. Yeah, I mean, in this approach, we could get to a similar point, right? This could get really long if I have a lot of components on my screen, but still at the end of the day, like that's what the screen looks like. That's what our screen state is, and someone else should be responsible for determining how that state gets there. But that was a really good question, though. I appreciate that. So let's go back to login actions. So from an overly pure theoretical standpoint, wouldn't loading and submitting be different states? Yes, I think they would. And I think that using a data class like this captures that too. But yeah, I guess that's a good point. Yeah, I don't really know. I mean, that's a good point. I think that's yeah. Yeah, I don't like. I think that it's a good point, but I think it could still go either way. You can go with personal preference, but correct. What Matt said is that a submit wouldn't trigger a state; it would be an action that triggers an action from some middleware. But even if that was the case, the action that triggers something could trigger a state change to like submitting. And I think at the end of the day, semantically, like we're going to do the same thing, whether we toggle this show progress bar or whether we change the state to be a different enum or different sealed class value. But I think it's a little bit I think at the end of the day, aside from a few niche theoretical things, it is one of those like personal preference approaches at the end of the day. Like there's nuances to both. A sealed class is nice because it's more a data class is nice because it's more flexible, but it's not as like rigid and type safe as like a sealed class. But you can accomplish the same thing with both. And at the end of the day, I like this because it's just one spot versus like a sealed class. You also have to worry about like what's in the base class and what's in each of the subclasses, and yeah. But it's personal preference. All personal preferences eventually become someone's best practices. Ooh, now I can't use the word best practices ever again now. All good questions on state. I really appreciate these. Let me know if you have more. I don't mind if you interrupt me, but I'm going to segue back into actions, which are the things that power our state. So I've seen a couple different approaches to defining like actions for a screen. I've seen approaches where people make login action a new interface, but I don't mind having a sealed class for some of the reasons we just discussed, is that we can just clearly define all of the actions that work with within our login screen. So let's talk about those. I can actually only think of like 3 that we need to worry about, which one is going to be like email changed. So this will be some text change to a new email, and that's a login action. Similarly, we can have password changed, which will be the new text there. And then we can have sign in button clicked, which will be a login action. Now, thinking ahead, when we actually go to like implementing a login request, we might want to put more here, like maybe like login started, login complete, login failed. Yeah, actually, let's put that in here, just so we have them. Login started should be a login action. Login completed, and then yeah, I'll just make this one. We could add like an error. Whoops. And then like for like login failed, we could use a data class there, and we could keep track of like what the error was that happened. As an example. So I don't know if we'll look at these right away. Like I said, it'll get trickier around there, but Matt is here to help me if I get confused. So these are all of our login related actions that we can have. So now that we've defined all those, and actually let me put some comments on there. These are all of the possible actions that can be triggered from the login screen. If you're senior enough, preferences often become best practice. I just saw that. And I think sometimes what comes from that though is like, if you've done something long enough, you prefer the things that work and that are quote unquote like best practices, but there will always be nuanced things that work for you that don't work for everybody. That's why I think like I reserve the word best practices for like 3 concepts, and they're more like conceptual rather than tools. Like I would say that using dependency injection is a best practice. Whatever you use to achieve that goal is preference. Architecture patterns are the same way. You should split responsibilities in your application. What pattern you choose to do that is a preference. But that's my real take on that. We've built our state, we've built our action, so the next thing we could do is build our reducer. So let's do that. Let's build a login reducer. So this will be a login reducer, and that will implement reducer. We're going to deal with a login view state and a login action. So that's nice because when we implement this method, okay, I don't know why it didn't, it will use those interface names for us automatically. So the nice thing about this reduce method is it's actually going to be really just a when statement. So we can say we need to return a new state. So we can say when action, and then we can do stuff based on what we got. So if our action is email changed, what we can do is return our current state dot copy, and then say email is equal to action.new email. So anytime we get the email changed action, we're just going to update the text on our state. Similar for password changed. We could do current state.copy. Password is going to be equal to new password. To give an example of like our login started, a way that might work. So if this is login started, for example, then we can say we want to return current state.copy and do show progress bar is equal to true. That's what we want to do with login is started. If this is login completed, we are going to return the same state, but show progress bar is false. And we want to do the same thing when login failed. I actually think we need to do that here. And this is actually, I don't know if you can see it, this is giving me a lit warning because there's a case that I haven't modified. And there's 2 approaches I kind of like here. I mean, the first one is that I could make sure my when statement considers every possible action. But let's say for some reason there's only specific actions that are actually going to manipulate my state. And maybe that's a weird statement, maybe that should never happen. But something you could consider is like, I have these actions I need to worry about, maybe new ones are added in the future. What I'm getting at is you can add a fallback and just say, if an action occurs that I'm not supporting in this else block, Samuel, thank you for the follow. If an action occurs that I'm not supporting, just return the current state, don't do anything. This is an opinionated approach to say that I don't need to worry about everything. You could go the other way and say you need to check every action, even if you say that action just submits the thing or just like returns the current state. You need to have it. So this is what your reducer looks like. And these can get kind of long. You can keep it like this, or just, again, another sort of preference recommendation. You could break some things out into private methods, so we could put like handle email changed. I did Command Option M to extract method. And so we could just pull these out and say, you know, handle new password. This is one way to have actions that have side effects that don't impact state. Right. So actually, like, one example of that might be the one that I didn't include, which is login button clicked, or sign in button clicked. So what this action would do in practice is it would trigger the sign-in flow, which would then call login started. So this action that needs to happen, this action wouldn't directly manipulate state, for example. So we could have it just return current state, but I like having the fallback. That's sort of opinionated, but you do lose a little bit of that like rigged state. There's also, while I'm here and while I'm going on slight tangents, I read a really good post about statements like this. And it was very good. I wish I could remember the name of it. But it talked about the idea of this method name. And they made the argument that this method name is actually really bad. Because the method name handle email changed doesn't sound like it's returning anything. And we've lost the context, especially if that were like down here. You know, let me do that. Let me show you. Like if I call this handle login changed, login completed. No, I don't know. Oh, because it's the same. This method name, handle login completed, just sounds like it's doing some side effect, and it doesn't sound like it's returning something. And we've lost the context that exists way up here, which is that we are returning something. It was a really good article that talked about how this is really popular in when statements. And when we write them, we understand that, but a new person coming in and reading this might not realize that that context is lost. So the one of the ways that I've seen it described is like, can you try to rename this in a way that's clear, like it's returning something? So like maybe we want to do like I can't think of a shorter version other than like get state with updated email. But that was kind of the idea, and like it's obviously not something you have to do, but it was a good thought, and I think that I don't necessarily like this phrasing, and rather I like the handle syntax. But maybe we could do like process email changed, something like that. Process password changed. That could be an example. Process login completed. State with action name. That's a good idea. So we could do like state with new email, something like that. State with new password. Or I could do like state after login completed. Something like that. That works. State after login started. I'm just going to keep going now that we've gone down that rabbit hole. Yeah, just a slight way of making it more clear that these are returning something. So that's our reducer. And this is the heart of what MVI gets you, is separate from having like a view model that's like a God class that's going to call all of these at different times. We have this very clear and predictable flow. I'm given this action, this is the state I'm giving out. I'm given this action, this is the state I'm giving out. And I can unit test any one of these. So maybe we'll look at that if we have time, but this is all just a standard Kotlin class. I could write a unit test around this reducer, no problem. So now that we have this, we can use it to build our store. And there's a couple ways to do that. Like we could build some store and have it injected via some dependency injection, but let's just create it inside our ViewModel for this contrived example. Oh, did I include? I didn't include some documentation here, so let's do that real quick. So this reducer is responsible for handling any login action and using that to create a new login view state. Yeah, we'll just leave it at that, but just helps give some clarity there. Do let me know in chat if you see that I like left out documentation that you think I should write. You know, I could even just say here, like, side note, notice that all of the functions are named in a way that they signify they're returning a new state and not just processing information. This helps keep your when statements clear, that they're returning stuff so that context isn't lost. I'll try to find the article that I got that idea from, but it was really, really good. Alright, so now we can go to our login view model. Like I said, we could have this passed in, but for the sake of this. So the reducer will call the endpoints. I haven't gotten to that yet. So I had like 99% of this stream worked out and 1% that I was going to wing it. And that's part of it, is figuring out the best way to handle that networking. But ideally you would have maybe like another component that would be responsible for making the network call. Hold on to that question, but we will get to it. But that's unanswered yet. So let's just start with this. So we'll create a private val here. We'll call it store, and this will just be our store class. We could say our initial state is going to be login view state, and the reducer can be login reducer. And so this, we want to expose a view state for our fragment. And what we can do here is just create a state flow, and that will return the state from our store. That's just proxying things through. And so the other thing our view model is responsible for, if we go back to our diagram real quick, so the view model, when certain view events happen, will then submit that action off to the store. So the view model now, instead of handling all of that logic, it's just the proxy for that information. So one way we could do that is we could have an open method here, like email changed. So whenever the view model is notified that our text changes, it can create an action for this. And then do store.dispatch action. Is there a framework that handles the boilerplate for you? Yes, there are some out there. I haven't used enough of them to like give my recommendation on them, but if you look up things like Redux Kotlin? So there is like a Redux Kotlin that I think is related, but it, or if you search for like MVI library Android, if you do a Google search for MVI libraries on Android, you will find there's like MVI Kotlin. I think that's what I was thinking of. Yeah, you can see. So there are some libraries out there, but I haven't used any of them enough to really push you in that direction. I also thought it was nice to explain it from the ground up and make sure people understand it as a concept. Because if you don't understand what the MVI libraries are doing behind the scenes, it can be really easy to use them wrong. But yes, for the part of this that feels like boilerplate, there are libraries that can solve that problem. But hopefully having an understanding of what they do behind the scenes, they'll become easier to use. So let's add these other proxies that our view model is going to need real quick, which are like password changed, and then so password and sign in button clicked. and store.dispatch. Okay. So those are really the only three proxies we're going to need. Yeah, that's a good point. I'll come back to the middleware. I know it's something we have to do, but I kind of want to just get through all the boilerplate before I get to writing the middleware. Something we can do actually while I'm here, before I go into my fragment. So the proper thing to do for a middleware, for like logging, would be to have like a middleware to do that. But I think something I might do just for the debug's sake in this is I'm going to put a log statement here. And then I'll just say like processing action. I'm going to put a log statement inside the reducer just so that when I run the app, we can see like in the logs what actions happen in what order. But when we go to the middleware section, we'll probably pull these out. It's a good idea to split up middleware because I try to logically break these down so when I push it onto YouTube, I can give the good channel markers and show like video markers and split it up. So cool. Any questions real quick on like the ViewModel thing? I think that when you think of it as just a proxy now, that's a little clear. So the next thing I need to do is some more like kind of boilerplatey code, which is run over to the fragment and then pass in all these, or proxy through to all of these. So let's do that real quick. Let's go into login fragment. I can actually get rid of this. I'm going to take this out for now. And let's go into onViewCreated. So when sign in button is clicked, we can call ViewModel.signInButtonClicked. We can add an email input. We can say do on text changed. We can call ViewModel.email changed text. And I'll just do toString or empty there. And we don't need any of these things here. So when our email input's changed, we call that. I'm going to copy this and just do the same thing for our password input. Okay. So when these things happen on our view, we proxy them over to the ViewModel. The ViewModel passes those actions into the store. The store will pass those actions into our reducer and update the state. Our ViewModel is actually not subscribing to the state at all. I can add that real quick. Let's add a method here. Let's just say process view state. So we could have sort of like a two-way binding here where we could say when, what I'm thinking of is like this line, is you could argue that we don't need this because the text input or edit text component is kind of managing that directly. But we could just be clear, like we're setting the text when we get the view state. Let's say for some reason we modify our view state ourselves, we could still do this. So we'll include it anyways. Set text will be password. I don't actually have a progress bar. So let's add that because we will need it. Let's go to fragment login and let's just add a progress bar real quick. Do I have my shortcut on this computer? I don't. So it'll be start to start of parent, end of parent. Oops. Okay, so we'll have this progress bar. We will start off with, hey Teal Shark, thanks for stopping by. We will start off by just saying that's gone. But this way we have the ability to show a progress bar when we need it. Sorry, little tangent there. Had to fill out some XML files. Let's go back to our fragment. So now we can say progress bar that visibility will be if viewState.showProgressBar, we do view.visible, else In my other project, I have an extension function for this, but I didn't include it in this project. That's our view state. We need to subscribe to this view state. So let's do that. We can do an onCreate. Do I have onCreate already? Oh, I do have onCreate already. So here we can do, oh wait. I need to add a dependency in order to use lifecycle scope. I knew that I needed this and I forgot to do it before the stream. We need a KTX dependency for this. So let's go on another tangent. Sorry, please forgive me. Doing a whole lot of this. This is now 3.1 to match the others. Okay. I need to get the lifecycle scope that I can, so I can actually deal with the state flow. So let's do lifecycle scope .launch. We'll do launch when resumed, and then we can do ViewModel.viewState.collect. And every time our view state changes, we will process that view state. So we did a lot here. Let's add a couple quick comments. So whenever the view is resumed, subscribe to our ViewModel view state flow. And then in onViewCreated, we can say whenever a relevant UI action occurs, like a text change or a button click, proxy that to the ViewModel to handle. And the thing we did before this was all these methods. So let's put that comment up here on the ViewModel. We can say whenever a view action occurs, such as email changed or sign-in button clicked, proxy the corresponding login action to our store. So I hope this documentation is both helpful to people who review this code after the stream, but also for those of you watching, that it forces me to sort of try to explain things in English a second time after explaining it in Kotlin. Let me know if you have questions up until this point. I might be going kind of fast. I was nervous tonight, and that means I go kind of fast, but please stop me, ask questions. If it's unrelated to the MVI code, like if it's related to something you see in the background, like let me know. I'm going to run this and try something out real quick. Very impressive how you type it with so few typos. It's because I'm extremely online. Okay, so let's filter out login reducer. Interesting. So these actions got triggered with empty text, which is fine. So let's type something in the email. I'm just going to type the word, ooh, okay. Maybe I shouldn't be resetting, I don't know if you can see it. I shouldn't be resetting the text myself because it's not, I've broken this. Yeah, let me go back. This was the wrong idea. I should have known better. We are not going to set the text ourselves because the component's handling itself. Self-implemented RTL, yes, exactly. So we'll just deal with this with the progress bar visibility. Okay, so we'll type in email, we'll type in test, cool. We'll go to password and we'll type in blah. Okay, and we can actually see here in our logcat the actions that are being processed in the order. So email changed is triggered every time we change the letter, so is password changed. You can see my password, I know. Also a note, if you add your own loggers, make sure you are smart about what you're actually logging. And then if I click sign in button, you can't see it, but you can see in the logcat that I clicked it. And again, and again. Okay, so that actually, without showing a more concrete example of actually making the login request and dealing with networking, that is MVI. That is Redux for Android. At like a fundamental level, I have shown you what the architecture pattern is. So if we were doing something that maybe didn't involve user inputs quite as much and it was like a loading content error state, you would be able to take this and build that sort of screen in MVI. I hope that's helpful. Let's throw this up. Implementing core MVI framework components and adding them to the login screen flow. Does not include networking yet. Oh no! It's okay, we still got more to do. And I can actually, this is actually a good point to do a brief recap of what we've done so far, you know, not including the middleware. So for Benny's sake, let's take 2 minutes to recap. So let's go back to our diagram. So this is everything we built. We have a fragment that takes those UI events and sends them to the view model, and we have a view model that exposes the view state via stateflow for the fragment to listen to. This actually is not there. Don't look at this yet. Doesn't exist. You know what? Boom. Doesn't exist. Our view model then takes these actions, converts these UI events into actions that it pushes off to our state container. That state container is also exposing a view state via stateflow. But when it receives an action, it passes the current state with an action into our reducer. That reducer takes that information, spits out a new state. Our store gets the new state, updates the view model, updates the view. So this is the loop of all the data in our application up to this point. And it's really nice to add this layer beyond just the view model because our reducer gives us very clear, predictable state management. Repository link, yes, if you do, I'll type it in for you, ! GitHub. It should also be posting every like 30 minutes, I think. But I should update my like description down below on Twitch with some of the commands that I have. Thanks for asking for that. So that's what we built. To briefly look at some code, I won't look at the interfaces. Let's just talk about the login portions of this. So the login reducer, that was sort of the beefiest part of this stream so far. We have a reducer that takes in our current login view state and some login action, and based on that action, it gets a new state. So if the email changed, we update our email on the new state. If the password changed, we get our state with the new password. When login started, we get our state after login started. If we look at these, what these do, these are just data class copy methods. So with new password, we copy the current state and we update the password property. For like login started, we're taking the current state and we're just showing the progress bar. This isn't actually happening from a user perspective yet, but we have the framework to do that in a moment. We have what else can we look at? Well, we can look at store, just to reiterate, even though we kind of saw it in the flowchart. We have a store that takes in our initial state and some reducer, and every time it has an action, it takes that current state, passes it into our reducer with the action, and then updates our new state. And then we can see both of those things really in action over here in login view model, where every time a UI event occurs, like email changed, we create an action associated with that event, and we send that action off to our store. And this is exposing whatever view state we got from our store. So we've got this clear unidirectional data flow. Everything is very clear and predictable. Every state change, and again, the importance of MVI, every state change is associated with a very clear action. Unlike just throwing everything into the view model where we don't really have that. So, hope this is interesting. But now we can move on to what I think you all were interested in, which is the idea of a middleware. So what happens in a flow like this where we want to trigger something that doesn't just manipulate state? So let's move these over because we're going to have to put new line in here, new spot in here. So I wish I had bounced this off of Matt before because I'm trying to think of how I used this before. I can't remember if a reducer or if a middleware, correct me if I'm wrong, Matt, a middleware should not output, should it or should not output new state? I don't think so. I think it can take in a state and then proxy it to the next thing, but it doesn't necessarily give a new state, right? So, right. So let's draw this out and let's figure it out. So let's say we want to add a middleware. So, but it can take in a state, right? So let's delete these two lines for a moment. Or rather, let's move these two lines to go in here. So I believe our current state and our action could go into a middleware, but then it should just output the same two things, right? Is that, do I have this right? I don't know if that works. I don't know if this is the right way to describe what a middleware would do. Yeah, so, well, this could be anything, right? Yeah, middleware, this could be logging, networking. So, but I think the note here is this idea. So current state should be unchanged, but action could be different than what went into middleware. Is this, am I wrong for saying this, or would you say that's accurate? Because I've seen this approach. Perfect, okay. I'll also, I'll have to do this after stream. I'll figure out how to export this, and I'll make sure that this gets added to the README, so you all can think about this. Okay, so another thing to note here is that you can have more than one middleware. I don't really know the best way to show that in the diagram. Like maybe I just do something like this. Actually, is that clear? I don't know if that's clear. So let's just throw like an S on here. Because you could have middleware that does a different thing. So Matt brings up a really good idea. We can build one that just does some logging. Logs the action, maybe the current state, and then we move on. Okay, so alright, I'm pausing because I'm thinking about the implementation, because I've seen apps implement this slightly differently. So it sounds like we could write a middleware that explicitly accepts an action as an output. And maybe that's what we should do. Let's talk about it. Let's go into our core. Not all middleware needs to work with all actions. Right. But I'm thinking of, so here's what let me show you what I'm thinking of, wait, what changed in here since I last committed? Oh, I added a comma. Let's make the middleware interface, and I'll show you what I'm worried about. So I understand the concept of a middleware, but I'm thinking of sort of what that would do. So do I have, so I've seen two approaches here, or I've seen one approach where great question from Monkey. I don't actually think the middleware needs to output a state and action to the reducer. It is seen as a middleware receives state and action, but doesn't output anything. Optionally, it can dispatch a new action to the store, though. Right, so that's what I've seen where, I've seen it like, let me write the method signature real quick, where it's something like dispatch where it's given like an action, and then you're given like the next dispatcher, and this would be like a dispatcher interface where it's given something that you then pass an action to. So your middleware could actually be like a linked list. And I don't know if that's more complicated than I want to write or not. That's what I'm trying to work through here. I don't know the way to do that. And so the way I've seen for apps that do it this way is you then sort of convert all of your middleware into like a linked list, and then the last item in the linked list is the reducer. So it could go through all the middleware, but it's eventually guaranteed it proxies through the reducer. I think we probably want to. I would think that we would want to worry about the order, but maybe not. I think, yeah, I don't think this would be as much for the order, but rather, if I left this out, it gives the opportunity for the middleware to not dispatch an action, for it to like fall short, but I don't know if you would ever want to do that. I've seen a library where like that was a thing, but I don't think you would want to do that. I don't think you'd want to like kill an action. I feel like it should make it all the way through, even if that does nothing. Matt, if you're still here, I'm curious how you might handle something like this. I could take a look at right, so that's what I want to start with, is like a logging middleware. So let's write out what I can, what I know that I want it to do, and then let's talk about where I would struggle. So I'm going to write a method here called dispatch that just takes in an action. And then do I want, yeah, and then the current state, because I might want the state in the middleware. So let's add that. Let's add, in our root project, we'll add a logging middleware class. So this will be logging middleware. It will implement the middleware interface and then override dispatch. So then here what we can do is we can say log.v, we'll just give it the class name, and then we'll just say processing action, current state, so this is what we'll get. We'll get something that just logs every time an action happens. This much I understand how to do. So one way we could implement that is we could have so let's just hard code this for a moment, and I'll explain exactly what I'm struggling. So there's our current state, right? So I guess what I could do here is I could just well, I want to keep track of yeah, let's just say we have 1 and it's our logging middleware. Okay, so in this example for logging, I could do something like middleware.dispatch action current state. So that's going to happen, and then we're going to get our new state. So this will work. But for like a networking middleware, where I then want to maybe submit a new action, right? So we have like our sign-in button clicked. This sign-in button clicked should trigger a network request that logs in the user, and then trigger a new action like login started. So how would I get that new action into my reducer? That's what I'm not positive I can do. And just to clarify, like I was actually thinking this should be a list, because we could have more than one. Let's run this just for sake of learning to make sure that I can do this and that this works. So I'm going to delete this other logging line. And we're just going to start there. We're just going to add this logging middleware. And take a look at the logcat and see what is output from this. Do a little iterative development here. I'll put this code up because this is what we just changed. Yep, so we can see the logging middleware processing what we expect. Your reducer can subscribe to a flow of actions. Send actions to that flow from the middleware. Yeah, that's similar to the idea from earlier of having like a next dispatcher or something. So it knows what to send the action to. Do I want to add a flow though? I don't really want to add a flow because then I need to put like scopes inside like the reducer. Let's take a quick look at since we know the name of what we're looking for, let's take a look at this MVI Kotlin library. I'll even blow this up. Oh, I wanted to see if it had an example. A library that I've used is this library called Bansa, which is like a state container. This is what I've seen that does a lot of what we've already done. But let's look at what their middleware class does, just so we know. It's in here somewhere. Yeah, so this library, they have this called a next dispatcher, which is like a thing that consumes the next action, and I'm wondering if that might be the way to do it. And then have each of my middleware be given like the next thing, but that can be kind of complicated. How do you do it in your apps? Do you use a flow and just have, and then what, pass in like the list of flows? Yeah, but where this gets confusing is like if we look at their implementation of store, nope. Their implementation of base store, that's where it gets confusing because it's like what am I looking for? They do this weird thing, so they have this populate dispatchers that takes in a list of middleware, right? And then it first adds to their linked list, like basically this is the reducer, and then it loops through all of your middlewares from the back, and then adds like a dispatcher for them that then passes it to the previous middleware, and so they create this like linked list. It's so confusing. Okay, Joaquin says neither for me. It's used as a pure side effect, which can in turn feed a new action into the store. So would you then, in the context of our project, on like the middleware.dispatch, would you then make the store like an additional property here? So instead of it being like a next dispatcher, it would be like we could have it be like, we could literally just pass the store as our next thing. But I think what I'm worried about then is how do I if the store calls the middleware and then the middleware calls the store, then won't I just be in an infinite loop of logging items? Like, I wonder if I'm like overcomplicating that. I wonder if I just did something like you know, like on complete of the middleware, I just have like a function that takes in an action and does something else, so that I could like tell the middleware. No, I don't know if I like that. I don't know why this is so complicated. Right, but so you can, but each middleware is responsible to only check for the actions it cares about. That is correct. But the logging middleware cares about every action. So if I want to log something and then spit back the original action with the intent that it will now go into our state reducer, then I don't know how to do that. That's the part that I've lost here. I mean, I can definitely rebuild this, but I'm afraid that I'm overcomplicating it for y'all. I'm surprised that the MVI colon didn't have an example. Oh, I see what you're saying. So I would only dispatch a new action to the store. I should never dispatch the original action to the store. That's what I misinterpreted about what you were saying. Okay, let's try that. That's a really good suggestion. Okay, let's try that. So we're going to update our middleware to be like this, where we take in the action, the current state, and our store. And we could, again, like earlier, we could make it so that our middleware is associated with a specific action and state. Let's do that just so we have that like ability if we wanted it to use generic types here. So our logging middleware then would be really any state and action. We can leave it there. This would be our store. Okay, and then we won't actually change anything about this. It will just be logging information. It won't process anything to the store. Okay, this is really good. I like where we're going with this. So what we can do then, what I want to clean up real quick, so here, this will be, let's add some comments on what we all just worked through. Starting in the middleware. So a middleware is any class intended that deals with side effects of actions. This can be logging, triggering network calls, and other examples. So I wonder if I should call it process, or maybe instead of dispatch, I wonder if it should be like process, because I'm not really dispatching anything. This will process the given action and current state and determine if we need to whoops, let me make sure y'all can read that. Form any side effects or trigger a new action. And then we can say for store, this is a reference to the store that that dispatched this action. We should only call this with a new action and not trigger the same action again, or risk ending up in a loop. Okay. A lot of words there. No typos. But that is our store. So we can go back to our logging middleware. We could say this middleware is responsible for logging every action that is processed to the logcat so that we can see the flow of our data for debugging purposes. Okay. So we've shown what to do with the logging middleware. Now what I want to do is I want to update our store to specifically say we want a list of middlewares. So this would be list middleware for some state and action. We'll say this is an empty list by default. But let's add some documentation here. This is a list of middleware entities for handling any side effects for actions dispatched to this store. So then what we can do is we will have our dispatch function loop through them all. We can go middlewares.for each. We will then do we will have it process this action, the current state, and this. So when our store dispatches an action, we loop through the middlewares, have them each process this action, and then we will finally pass it through to the reducer. So in the example of, say, like our sign-in button clicked, what we'll get to is a point where the sign-in button will go through our middlewares. When it hits the networking middleware, which we'll write next, it will submit a new action back to the store, which that eventually goes through everything. But the middleware and the reducer, if they don't care about an action, they will just ignore it. So this should all work out. So let's try this out. What we need, so we can run this. Let's just run this and make sure I can like type stuff in and click the button and nothing breaks. So we can do like testy, make test face, sign in. If we go back here, why was nothing? Oh, because I made this an empty list, so that the view model who's creating it can specify stuff. So we can do list of logging middleware. Oh, interesting. Okay, this is giving me a type warning because in here I said that the middleware needs to match the same state and action as the store itself, but with the logging middleware that's not exactly the case. So let's not make that requirement on the middleware, at least not for our base store class. We can still make a middleware that's scoped to a specific type, but oh god, why are you yelling at me? It's because yeah, I think that's probably the way to do it because I've got, okay, let's get rid of that then. Let's make them accept anything as long as it is that type, of course. This should work now, no? Required store of state and action, but found store of S and A. I mean, that should still work because these types S and A, they are from state and action. So why doesn't this work? generics are hard. Is this where I might need, like, the variants? But I don't think so. Okay. Let's see if we can find it. The out keyword means you want any subtype could be assigned to a super type. Yeah, so maybe that is what I need because I've seen that before. Yeah, that's what it was. What happens if you have the same S store in your middleware or state? Well, that's what I did have. Wait, so why doesn't this work now? Maybe I want to put that out on the middleware itself. Let me try that. Oh, hold on. That changed. I fixed one issue, but then now, nope, I did not fix it. I think what I had was going to work as long as I put the out in this one. This would be A. No, I can't use it in a function if I do that. Is there a way to be both? You missed the E. No, I'm looking at like if I label something as out in the generic type. Oh, I missed the E. But that's still okay, but here if the parameter is declared as out but it occurs as in, oh right, because it comes in here. Maybe I shouldn't have made everything generic. I could remove the generics from my store. Let's remove the generics from the store. And just make these use the actual classes. Just so I can unblock myself and maybe we can look at the details later. This will have to... Why are you? Why? Oh, well, okay, so this middleware needs to be updated. Login reducer is fine still. I bet I can make reducer. Oh, no, I can't do that here. Yeah, we're just gonna remove them all for the time being until I can. Whoops. We'll make generics a separate pull request when we configure it out. But let's get rid of everything until for now. But now I've lost the ability to put to say the store is a specific state type. Classic stream. Okay. I feel like I was so close to having this right. You may have needed generics on the logging middleware itself and pass them to generics in the middleware interface when implementing. I thought I had done something like that, but alright, let's whoops, nope. Let's go back. Oh god. I went back too far. Let's go back and add these. I want to go back because this is what I want to work. So let me go back to this and let's try to make it work. Ah, thank you. Thank you for making me hydrate. Maybe I'll think more clearly now. So good question here. If you want your store to, you could make your store only have a generic state, but then any action. I think that is like an idea, but I think I would run into the same problem just with one parameter instead of two. Lost here, hold on. Oh, S here. Wait, but now I'm on that, so generics are always annoying. I know, but if I can get this to work, then that's what I want. Let me run this. Let me see what comes. You think login middleware needs generics on the definition of the class. So you're saying like here? And then instead of, and then doing something like this? Or, maybe. Right, I'm having a generic... Right, okay, so instead of putting it here, I'm forcing you to specifying it. I'm forcing the caller to specify it when they create a logging middleware, which means here, I can put... Why did this... Are those defaults? Why is this not yelling at me? Alright, we're closer. Oh, this needs to be S now. Okay, I got rid of the errors in login ViewModel. Our store still has some errors. So, oh, I need to update dispatch to use my type here. Okay, I think actually what Matt suggested fixed it. I think by making these, by putting them on the class, we fixed it. I think that was hidden all of that. I think that was the change. Because now the app runs. Okay. Interesting. And it's also interesting that by putting this though, that like, I guess the types are inferred here when I pass it, that because of the type inference here, that it knows like login view state and login action from the other stuff, it's probably inferred here. Let's open up our logcat and let's type some stuff in. Yeah, okay. Wow, alright. That's it. Okay. Nailed it. First try. Starting with logging middleware. If I figured it out before I committed, it counts as the first try. Instead of having 20 commits, they say testing Travis. In case you're wondering how my workday went today, that's how it went. Awesome. All right, so let's do a networking one. Okay. So what are some things we need here? Let's create some of the app code that we might need. Let's make an interface real quick and call it login repository. We'll make a suspending function that says, do we want to make it suspending? We do, but this is going to get tricky. Let's make it a regular function for now. And then we'll talk about suspending stuff later. So let's just say login with an email. Let's make this super contrived for the start, and let's just be like, I don't know, like, let's just have this return a boolean. We'll just make it super contrived. This wouldn't be what happens in like a real login scenario, but we can show it off. And then we can make an implementation, call it like prod login service or something. And this will extend our login repository. We have a function. Let's just say return true. Like, we're just going to simulate like a successful login. I wanted a suspending function so I could delay on purpose. Gotta hydrate. Thanks, Megan. I wanted to make this a suspending function so I could show the delay. What made me nervous is that now we have to think about coroutine dispatchers and all of this. And I didn't know if I wanted to do that now or if I want to build this and show that it works and then like add the suspending later. Let's try that. We can keep going. I'm thinking of how that I'm going to show some stuff on the UI, but let's come back to that. So we need now, similar to logging middleware, we want to add another one. Let's call it like login networking middleware. So we can have a login networking middleware. Am I gonna have the same problem where like I need to put, let's do it for now. Okay, so we have this login networking middleware. Specifically, this one is going to need a login repository. And so what we can do here is we could do something like when action. We could say if this is login action dot sign in button clicked, okay, then we want to, gotta hydrate for prints. We are first going to dispatch login started, or we're going to dispatch login started. Ooh. But this is, I have more generic troubles. But this is an action. This should work. This is why I wish if I could make this middleware to say specifically like login action. I don't think that would work, but oh my god, generics are going to be the death of me today. So this is one reason, I think actually this is one reason I considered not using a sealed class, because I think that's why it's confused. If I did something like, and I just had this implement action, you need to do it at the class level. Didn't I? Or are you saying that like here? Like instead of these being... No, that still didn't do it for me. Gotta hydrate again. I'm gonna have to stop for a restroom break before we figure this out. See, what I was thinking of is, that's one of the reasons I was worried about using like a sealed class. Because if I pulled something out here, if I did like login started test, right? And I had this implement action, and I did login started test, then this would, wait, nope, it still wouldn't work. Because it's not viewing it as A. Why not? Okay, the question was, why can't this be, no, your code didn't get censored, I can see it. Why can't that extend middleware, login view state, login view action? So, we tried, okay. So we tried this before. But then we just got a whole bunch of, right. So it actually was fine in here, right? So this class, whoops, let's make this easier to read. So this class was fine. Where it complained was inside login ViewModel when I added it to my list of middlewares. So if I want to do LoginNetworkingMiddleware, wait, it's not yelling at me. Didn't this yell at me earlier? Didn't I do this? I think I know why it's not yelling at me. Ooh, I think I know why this didn't yell at me. So, my store is of type... No. My store is of type login view state and the login action, right? And so is my middleware by doing it this way. But if I were to change these to the regular state and regular action, because they're a super type, that's why it was yelling at me. But in this case, because I think it's kind of luck, because it matches what the store is expecting, this just happens to work. Okay, so we can do store.dispatch login started, and then we'll just say for now is successful. We'll say login repository.login. Ooh, I guess we need, well, we could do email equals current state.email. Password is current state.password. And so then we could say, like, if is successful, we want to do store.dispatch login success, whoops, login completed, else we'll do store.dispatch login failed. Oh, and we won't say what the error is. We'll just put null here. Okay. So this is what our logging middleware will do. And let's just, I don't care about the rest. Can I add a lint warning here? I don't think I can. Press suppress. Okay. So when sign in button is clicked, we want to log in the user. So we dispatch login started, we make our request. If it's successful, we process this. Otherwise, we process login failed. This is claiming to be red, but I don't see it. I don't think it's actually red. So let's run this. Oh, did we add it to this? Yeah. Okay, so we've got our logging middleware, which is going to track stuff. We're going to put in, I'm just going to put in one letter for each thing, and then I'm going to click sign in. Nice, okay. And this, I don't see the progress bar because it's all lightning fast, but we can actually see here the order of operations are what we expected. So it prints sign in button clicked, it prints login started, login completed. Sign in button clicked, login started, login completed. So we can see that our middleware does process things all the way through, which is really nice. We can actually look, if we want to, check this out. So login started, show progress bar false. Login completed, go across the same line here, show progress bar equals true. So using this debug, we're actually able to see proof that our middleware and everything is working together, and our state was updated accordingly via the reducer to make the progress bar true after login started. Yeah, this is really cool. So the only thing that this doesn't do, or that I would like to make this a little nicer, is make our dispatcher be able to do something on like a background thread. If y'all want to hang around and do that, we can do that. I am going to take like a 30-second break to, I'll use the restroom, refill my water. If y'all are hanging out, you should feel free to get up and stretch your legs as well. Middleware. Adding the logging networking middleware. Yeah, so let's thank you both, Joaquin and Matt, for helping me figure that out. That was, the middleware stuff, I feel like if I go and look back on it, now I understand it a lot better, but that's every stream. But it's always hard to figure out going into this. God dang it. Cheers. But that's the end of my water. So if you want to keep torturing me, we have to take a short break. Okay, so yeah, before we do that, I always like to pause and do like a little recap of what we did, especially when things get confusing, and when I get confused, it's important to go back and rebase ourselves, so let's do that real quick. We added a middleware interface that processes an action and a current state, and then it has a reference to the store, that if our middleware needs to process a new action, it will process that, it will send that back up to the store. The changes we made to our store, which is our state container, is that when it goes to dispatch an action, it will first process through each of the middleware and have each of them take in that action that was run. And then once all of the middleware have processed the action, it will go into our reducer. And so far we've added two middleware. The first one is a logging middleware, and all it does is print out to the logcat what the action was and what our current state was. Important to note that this does not reference the store, it does not pass the action back, otherwise we could have risked ending up in a loop. Then we added our LoginNetworking middleware, which looks specifically for the sign-in button clicked action. When that happens, it sends off a new action to the store called login started. And what this does from our reducer earlier in the stream is that it shows the progress bar. Then we make the request based on our view state. Notice here we're not actually doing data manage or any sort of error validation, but we can do that when we come back from the break too. And then based on whether or not login is successful, it's going to dispatch a new action, either login completed or login failed. And this could be the actual error, but we just have it as null. I can wait a couple seconds. Let me know if any of you have questions before we take a short break. But what I can do, oh, I don't have it up. I was going to do another fancy countdown timer. But let's say literally 5 minutes from now. So that's 8:45 Eastern time. We'll come back in 5 minutes and we'll try to update this to show how it would handle like an asynchronous flow. Like if our login call was inside a suspending function, how would we update this middleware to be able to support that? So hope you can come back in a few minutes, stick around. Y'all should get up and stretch your legs and get some water too. Hydrating is good for you. I'll put some lo-fi back on. Thanks. Alright, we are back, and I guess this is just the water drinking stream now. That's the reason I set that 2-minute cooldown on this reward, because otherwise I would just be chugging water for 2 hours. But here's one for Megan. And another one for Prince. Alright. Welcome back. We're ready to keep powering through a little bit longer. A huge shout out to all of you for hanging out, and for those of you who helped me get unblocked with a lot of stuff. Just to kind of recap again, I said this a little bit earlier, but at this point, if you followed along with the stream so far, this is a great job. You can say now that like you understand MVI as an architecture pattern. There will be a little bit of nuances as we go through, like if you did want to go down the path of like making sure your middleware run in a certain order, or what we're about to do, which is working through like how do you have your middleware do some asynchronous code. There's always these little nuanced things, but we're getting into what I would consider more like advanced MVI stuff. Don't feel like the questions you still have mean that you don't understand or can't start using the architecture pattern. I think if you understand what state and action represent, if you understand how, like what the job of a store is, and you understand why we need middleware, then you've understood this architecture pattern, and everything else after that is more advanced, nuanced questions. So proud of you for hanging out to this point. If you learned something, I'm really glad. If you have questions, do let me know here. If you're watching it later, reach out to me on Twitter. My DMs are open if you don't want to tag me. But I'll happily help you figure out whatever it is that you're working through. I think this is a really great pattern. I think what's hard sometimes is to think about the fact that we've spent 2 hours working on a login screen. I think that, and part of that is because we went through the boilerplate of discussing MVI and how to set up those core interface classes, but you could definitely say there's a lot of code here for a screen that has 2 inputs and a button. And that's why for like 95% of cases, or arbitrary number, for a lot of cases, something like model view ViewModel is great. If you're working on a screen that is fetch and load some data and display some data, you don't really need all this fancy state management. But if you have a screen that has a lot of user inputs and a lot of moving components, having this predictability helps a lot. It also breaks the code down into a lot of smaller files rather than one big file, which is nice too. Someone sent a question on the link above. Yeah, let me go take a look at that real quick. So I see 2 here. One is, are we going to modularize the project? It's not something that I had intended to do here. I've had requests on like how to work with a multi-module project, but I haven't done that in a while. So I haven't put it here. And then a question on like how can I scale the project with this architecture? So as far as scaling on your project, what I like to think about is this pattern sort of applies on like a screen-by-screen basis. So a great example to point out is like specifically like the login reducer. So we have this login reducer, right, that has like your login view state and a login action. And we use generic types to specify that we have to be one of these 2 things. And that's a really nice way to break down your reducer to some specific screen or scope. And so all you would do to scale that is take this idea and make like a profile reducer that has like a profile view state and a profile action. And you would just create one of these classes for each sort of feature. Or not feature, but each screen. You should update your diagram. I think it will make it clear. You're right, we should update the diagram. That is not optional, because after the stream I intend to like export this as a GIF. Okay, so let's delete these 2 lines because this isn't true anymore. Let's move this. Oh god. Let's delete this extra one. Let's clear this up. So what we should have done is, I want to move this. Let's move this up here. This is not great. Let's move back down. That's fine. So let's clarify something we changed, which is that, or go back to what we had originally. So our store passes in the current state and an action into our reducer. That gives us a new state. But how do I signify that? And what changed is instead of our middleware going to the reducer, the middleware will dispatch a new action if necessary. I want the diagram to first understand, or whoops, alright, so were these were not tied to the box, I guess. I wanted to find a way to note that this happens after the middleware. So even though the diagram goes from here, it goes from the store to the reducer, this still happens after we process through the middleware, right? I wonder if I can just add some text to this and say, like, this only happens once the action has been passed into each of the middleware. Can I make this no, I want that to be black. I want to see if I could put a background color. And then I was going to put a little arrow to, like, this guy. Let's do this here. I'm overcomplicating it. After processing through middleware. That could be our note here. Okay, hope this cleans it up. This is really, thank you for catching that. This is really important to update this diagram. So people who see it after will definitely be able to follow through with that. Cool. So, double check, I answered those 2 questions. They were great questions, thank you. We updated the diagram. So let's talk about asynchronous stuff. I think this is a good one. This is actually a little tricky. So let's look at our login repository. So we said we can still keep it a Boolean for some sort of like contrived example like this, but we did say that we wanted to make this suspending. And that's fine. We can override this. And that allows me to do what I wanted to, because I wanted to make sure that we can see the progress bar. So I thought about putting like delay for 2.5 seconds, or we'll just say 2 seconds. So we can simulate like a delay making an actual network request before we return true. But now what's broken is our LoginNetworkingMiddleware. Specifically right here, we've got suspend function login could only be called from a coroutine or another suspend function. So there's no, gotta hydrate, thank you. We're entering a territory of potential sort of personal preference again, which is sort of like at some point we have to switch into a coroutine. We have to switch, think of it as switching threads, right? We have to switch onto a background thread. And where do we do that? Do we go as far as making the middleware function be suspend? And then anything that calls the store needs to call it from a coroutine. That's an option. Another option is to have this process function trigger a coroutine itself. And that's kind of the route I was thinking about going. But then the question would be, well, okay, we need to launch a coroutine in a scope. If we were doing this from a view model, we would do like ViewModelScope.launch. And arguably that's potentially one reason for making all of our store stuff be suspending. And maybe I'll go back on that, because my first thought, maybe the easiest thought, was, well, what if I just pass in the coroutine scope into this process method? Or I pass the coroutine scope into the middleware. But now that I've said it, it feels kind of hacky. It feels like maybe I should just make this suspending. And then I would have to go into here and make this suspend. And that's all good. We would need to update some other stuff, but then we would update our store. This would also have to be suspend. But then what we could do is, we make all of these suspending functions, and then the real key is inside login ViewModel, where if I want to dispatch something to the store, I have to do that on a new inside a coroutine. So here I could do ViewModelScope.launch and then do store.dispatch action. What do y'all think? Do you feel like this is probably the best way to do it, as opposed to having dispatch create its own scope? I kind of think so. Even though it felt easier to have dispatch launch the coroutine, I think in general it'd be good to make all of the store stuff happen asynchronously, make them all suspending functions, and then have the view models be responsible for launching the asynchronous work. That's just my 2 cents. But I'd be curious what this would then mean for like a cancellation exception. Maybe we can test that later. But let's go with this for now. We've got... I need to update my logging middleware. This is also a suspend function now. But I think for the most part, actually, that's it. We made our login repository. We made this a suspending function. Then we made everything that touched it a suspending function, because you can only call suspending functions from another suspending function. But that bubbled up to login ViewModel, where we call ViewModelScope, which is a coroutine scope tied to our ViewModel's life, or it's not a life cycle, but tied to like the history of this ViewModel, and then we launch a coroutine to dispatch an action. And the other benefit we got from this is in our fake login repository, we delayed for 2 seconds. So we can test that all of this works visually now. So I'm going to go to my screen and I'm going to type in some dummy info for email and password. And then I'm going to hit sign in, and we should see the progress bar for like 2 seconds, which we do. And then it's gone. So we can see visually, even though we don't have any sort of navigation yet, we can see that this suspending function works. So that was actually a lot shorter than I expected it to be, but good old quick restroom break clears your head, and stretching your legs and getting some water. So let's commit this, and let's say we changed login repository to a suspending function, as well as the store and middleware implementations. So yeah, that's cool. So at this point we can really just, I don't really have any new ideas related to MVI, but we could continue to hammer in the idea by talking about how we might like add some new features, new capabilities to it. Like let's say when I want to, let's say when I sign in and I have an empty email, that I want an error to appear instead. Let's talk about how we might do that. And I think we've been streaming for a while, so maybe we'll do the email error, and then, I don't know, we'll see where we get. So, let's think about something we might want to do. Well, we know that when an invalid email is submitted, that's going to manipulate our state. So a place to start is there's an action here, and that action is like invalid email submitted. So we can go into login action, and we could make something here like invalid email submitted. And we won't keep any information, we just know this action happened. And now that we've created that action, we need to go into our reducer, our login reducer, and set up a scenario that says when this action happens, give me this new state. So we can say login action dot invalid email submitted. Here we're going to return current state dot copy, and we can say email error is going to be instead of invalid, just an empty email for this use case. So we can just say please enter an email address. Great. We also need our view state to be able to respond to this, or our view implementation. So let's go into login fragment, and where we have process view state, we can track this. So we can say binding dot email input. We'll put this on the text input layout. We can say error is equal to view state dot email error. Thank you for the follow, Adolisto. I hope I said that right. And so we've created an action. We've updated our reducer to handle this new action. We've updated our view to support this part of the view state. What's missing is something to trigger this action. So here's how we're going to do that. We're going to go to the LoginNetworkingMiddleware. I'm going to take this code that we already wrote. I'm going to put in its own function and just say login user. But before that, I'm going to do a validation check here. I'm going to say if current state dot email dot is empty. If the current state that email is empty, we're going to do store dot dispatch login action dot invalid email submitted, and then I'm going to just return. I'm not even going to try to log in the user. I'm going to dispatch that you had an invalid email, and then I'm going to return. Cheers, another hydrate. And that actually should be everything we need. Let's run it and try it. And while we're running it, keep thinking, once you've set up this framework, and this goes back to an earlier question on like how do we scale this, and if you're thinking of scaling as new features, once you have this framework set up for MVI, you'll find yourself sort of following that pattern. Create an action, update your reducer, handle the view state, and trigger whatever you need to do to send that action. And that was actually true from the beginning. We created some login actions, we made a reducer that processes those actions into states, and then we made all of the proxies to trigger those actions. I guess it's the same idea that we started with, but there was a lot of work that went into just getting started with all of that. So I'm just going to hit sign in from here. Oh no. Alright, we did not get an error. Let's look at logging middleware. So invalid email submitted is processed, but our state isn't updated. Interesting. Let's go back to login reducer. Make sure this is called. Yeah, current state.copy. No error. Let's look at login fragment. Let's try this. Okay, so that's not changing, but let me run this again. It's possible. Okay, so this is fine. That's our initial state. Let's hit sign in. That's so weird. I'm not getting the update. Alright, this is the part of the stream where we debug stuff together. I think it's here. So let's abstract this out. Yeah, this is the same as everything else. Whoops, state with. We return the current state.copy, and we set the email error equals this. That should update our state. Why doesn't it? Let's go into, oh man, let's go into store. What's the problem? Okay, so I wanted to add an invalid email error. So what I did is I made a new action called invalid email submitted, and then inside our login networking middleware, I do a quick check. If the current state email is empty, I dispatch this action, and then I return. So I don't do any sort of, I don't actually log in the user, right? Over in login reducer, we added that to our big when statement. If invalid email is submitted, we get our state with an invalid email error. And all that does is just say email error is this string. And I updated the fragment so that I set email input layout.error is equal to the email error text. But over here, when I click submit, nothing's happening. Now, I wonder if my bug is actually here. No, I don't think so. No, because I know this is called because I can see from my logging middleware that invalid email submitted is triggered. It's a text input layout. So I actually think that, are you going to talk about testing? We can. I'd consider that as an option. If you want to look at testing, yeah, let's, after I figure out what to do here. I don't think I need an else. So where I'm thinking is, because I know this is submitted, I know that this action is being processed. But one thing I'm noticing is that this email error equals null is true in all of these. And I don't know why. Like, at some point this had to have changed. So I was going to go, next I was going to go into my store, and I was going to put a breakpoint here on new state. And just like, so here I can see it, actually. I can see, in the current state, email error is null. In the new state, we get please enter an email address. Ooh. I wonder if we have a race condition of some kind. Because now look, right after that, because now my second breakpoint, oh, you can't see this, but now the action that was triggered is sign in button clicked. It's like a race condition. So the sign in button was clicked. That triggered the invalid email to the store. That runs through and gets processed by the reducer, but then the sign in button clicked, finished going through the middleware, and then it gets processed by the reducer with... so I think what I should do here, actually... So when dispatch is called, I get current state, and then all these things process, and then I use the current state. But I think what's wrong is that if while this is happening, the backing state flow changed, I'm referencing a stale value here. So maybe I should get rid of this line, and then everywhere I want to reference it, I will take in what the real value is at this moment. Instead of keeping track of what state was when dispatch was called, instead I want what state is like at this moment. I want to get that updated state every time. So let's try that. Let's see, that might be what my issue was. Look at that. Please enter an email address. Okay, that was tricky, but thankfully for breakpoints. Really interesting bug there. There's still, I guess, the possibility that what we just changed it to look at state every time could introduce some interesting behavior, but I think this is actually what we wanted. I was going for readability earlier. Maybe I shouldn't have done that. Or maybe I could have, like, if I wanted to, I could do like and then put this as like a private thing, and then every time we get it, return state that value. So that we can get that readability of still having like current state, but making sure it's something that we read from every time. Let's make sure that that actually works before I commit that code. Yeah, it does. That's really good. Awesome. Yeah, let's push this. I had a question in there about testing. Why don't we talk a little bit about testing, and then we can wrap up for tonight. So what did we change here? Added email error example. So, I believe it was Dan who asked about testing. Is there any specific sort of component that you are thinking about testing or want to test? Because there's a couple ways I think we can break it up. Maybe one place that's like a good place to start is in like we can write a test for like our reducer that says like, we can create a reducer, give it a state, give it an action, and make sure we get what we expect out of it. We could write a test around like a middleware. I suppose for this one it would specifically be like the networking middleware would be easier. Or you can go kind of full-on integration test and create like an implementation of the store, and then have be able to test like your reducer and middleware together as like a possible thing. I don't know if you want to look at all of those or maybe one of them specifically. Let me know what you're thinking. All of those. All right, let's start with one at a time. Let's do Okay, let's do I don't know which one I want to start with. I'm glad you're learning so much. I'm glad. Let's start with the reducer, because I think that one will be the most straightforward to test. So we're going to go into login reducer. And I'm going to use one of my favorite Android Studio shortcuts, which is Command-Shift-T, which is for create new test. And then it defaults to login reducer test. We'll make this JUnit 4, and then we hit OK. It will ask for a directory we want to be in the regular test directory. And hit OK. Testing the reducer is probably the most powerful reason. Yeah, I agree. I think it's like the crux of all of it is that state management. So you want to test that that works, right? Okay, let's, I'm gonna, okay. So let's test the email changed example to start. I'll write the test and then we'll look at, maybe if there's better ways we can clean it up. One thing I'm going to add real quick, I always like to give a plug for this. If you've ever used Truth, which is a Google library for just writing more fluent assertions in tests, so instead of the JUnit like assert equals, where you give it like the expected and actual values, you get this really nice syntax from Google where you can say like assert that this thing contains something, or assert that this thing is equal to another. So I'm just trying to find where the dependency is and add this, and it just makes the test a little nicer. So we're going to do that real quick. Okay, so let's start off with our first test, which is, we'll say email changed. So each of our tests can follow like the same format. So let's think about what our reducer is going to do. Well, our reducer has an input, so we can have like an input state, and this will just be a default state. Then we have an input action, which can be, you know, login action.email changed, testy at mctestface.com. I'm very, yeah, all right. We have our given input state and input action, and then we have like our expected state after this action, which we'll say is, it's going to be our input state.copy, and then we expect it to have an email of testy at mctestface.com. So then, given these inputs, we then can create a reducer, create our login reducer. We can say, you know, new state is going to be reducer.reduce, input state and input action. And then we want to assert that our new state that is equal to expected state. Hope this test is readable. It follows the standard, some people say like given, when, then, or there's one with like 3 A's, something, action, assert. But let's run this test and let's make sure it passes. But then what we would do, I won't write one for every action because I want to get through all of the examples that you asked about, but we can write like 2 or 3 of these, but they'll all follow the same format. Cool, email changed passed. Let's talk about one, you know, and we could rename these tests to where like, arrange act assert, that's what it is. You know, we could say like email changed updates email. We could be a little more clear, and what I mean by that is we could then go to a test like, we could say login started shows progress bar. So another way to look at these tests is if you don't want to, I mean, I suggest that you run an assertion against like a specific state, but you could also assert against like a specific property. So for example, let's say we have our input state is login view state, and then our input action will be login started. We could create a reducer here. We can get a new state with our input state and action. And then if we don't want to assert the whole thing, but we just want to say when this login started action occurs, I show the progress bar, we can do, I love this, assert that new state that show progress bar is true. And so this is a really nice way, like if you want to like scope your test down to checking a specific property. Because maybe for testing's sake, you don't care what else this does to state, you just want to make sure this thing happens. And that's a little opinionated. I think that we should do like the expected state example above, so we make sure that it's truly exactly what we expect and we don't have any accidental side effects to this. But I just wanted to show this as like something you could do with like the truth library from Google, and you could scope down your tests. So let's add a note like this. Let's add some documentation around these two examples. So a standard reducer test will take an input state and input action, and have the reducer reduce that into a new state. We then want to compare that new state with what is expected. So that's a standard test. We could say an example of a simplified reducer test is to take an input state and action, have the reducer reduce this to a new state, and then perform assertions only on the properties we expected to be updated. This can make for simpler and shorter tests, but it acknowledges but we should acknowledge that this means potential side effects could sneak in our tests. So I'll leave it in here for like sake of GitHub history, but good comments here on like why these two tests might be different. And let me know, Dan, if you have like other questions, but I actually think two tests are good for showing how to test the reducer. Because what will happen after this is we'll just have all of these tests following the same format. An input state and input action and get the output. We would basically want to write one test for every action. Maybe another good case, just as a third one, is to test an unsupported action. So something like this, say like unsupported action, or let's say unsupported action returns original state. So input state could be our login view state. Our input action, one that is not supported by a reducer, is like the sign in button clicked. So then we can say reducer equals login reducer. New state is equal to reducer.reduce. Input state, input action. And then here we can say like assert that new state is equal to input state. So this is just a nice test that tests the fallback scenario. Let's put a comment in here. This test ensures that our fallback scenario, dispatching an action that isn't processed by this reducer, will return the original state. Will return the original state. And let's run all these just to make sure they all still pass. Cool. They all still pass. So that's testing the reducer. Let me know if you have any questions on that. Or I can move on to showing an example of testing the we could do the networking middleware. That will be an interesting one. It's kind of difficult one, I think. Maybe not. We'll see. Added unit tests for login reducer. Okay. I also kind of made an assumption that you might be familiar with some of the core testing concepts of like what like assert equals is. But I think that it's readable. I think that assert that this is true is something. You can understand what that's doing behind the scenes. Let's move on to networking. And this one's a little trickier because we have to deal with like a little bit of mocking here. Specifically, like this is a little tricky because we have like this store class that we have to think about what that would do. But let's make our test class and then we'll talk through it. Using the same shortcut as before, creating this class. So one thing I want to do before this is, our middleware has a dependency on a login repository. And so what we need for our unit test, because, and I'm glad I named it this way. So in the project, we named it like prod login service. We don't want to use that in our unit tests. We don't want our unit tests to actually, well, maybe we do, but if our focus is testing the middleware, that the middleware behaves as expected, we don't want it to depend on some production component that we can't manipulate the behavior for. So this is where in testing, people talk about like mocks or fakes, creating some fake implementation of something that you, the developer, can manipulate during unit tests. So let's say like the reason why we don't have our tests go to like a real production service is like, what if I want my unit test to test like a login failure? Well, if I want to test that, I need to like break the backend in order for my test to fail. But if I use a mock, I can tell it to mock the failure. Now there are libraries that can do this, but what I'm gonna do is create like a fake implementation. So I'm gonna create a new file and I'm gonna call it fake login repository. And this will extend login repository. And what we can do for this example, for like our fake, is we could give it like a public variable called like should mock success. Make that a boolean and we'll default to true. But in our tests we could change this. We could say this should be false or something like that. And then what we can do here is we can just say return should mock success. So this gives us the ability to call into this class and determine whether or not it should return true or false. Let's go ahead and document this. So this is a custom implementation of login repository that allows the developer in the unit tests to determine if a login should behave as a success or failure scenario by setting the should mock success boolean accordingly. Good question. Before I get to that, another thought. I don't know, whoops, I did it again. I don't know if y'all have seen this, but the reason I put certain things in brackets is because this creates like a link inside your IDE. So if I command click right here where it says login repository, it takes me to the login repository class. And if you use like a documentation generator, you'll get like the HTML link in there, so that's really nice. My personal preference is fakes, but you can do both. And let me see if I can find it. Sam Edwards has, where is this thing? There we go. Sam Edwards has a great blog post where he shows that you can use Mockito, but doing it by wrapping it around a mock implement or a fake implementation, which I think is really nice. So you get the benefit of using Mockito, but you don't have it super tightly coupled in your code base. So that's really nice. I think that my preference for fakes kind of came over time because Mockito definitely saves you a lot of boilerplate, or Mock-K is another approach. But then over time I just ran into enough nuanced scenarios where I was like, all right, I want my own implementation so I don't have to deal with someone else's code. But the post I just linked from Sam Edwards is a good middle ground. Okay, so let's when would you use mock or fake? I mean, I think that it's preference at the end of the day, but you should use one of them when you're testing something and you need to provide like a custom implementation um, of something. So like this one where we're about to test our middleware. So let's create a test. Let's call this one, well, let's do the invalid email option. So we'll say, submit invalid email. That's what we want to test. So we can create our fake repository, fake login repository. We can say for this test, that should mock success is true. I know that was the default, but let's set it anyways. So then we can create our middleware. So we can create our middleware, which will be LoginNetworkingMiddleware with fake login repository. But now it gets tricky. So let's, well, hold on. Let's go back over our givens. So we also need our input state, which can be a login view state. We also need our input action, which will be sign in button clicked. We should also, just to make sure this test is clear, because this is the invalid email, let's explicitly say that email is an empty string here. So we've got our middleware. So now we need when. So we want to write here, we want to test middleware dot process. We can give it our input action, our input state, but we also need to give it a store. I'm trying to think of how to do this. So let's talk about what we want this test to do. And this might actually be a case for rearranging some of our architecture. So what I want this test to do is say when I call this with this action and this state and this store, what I'm expecting to happen is that the middleware dispatches an action to that store. So what would be nice is it would be nice if store were an interface and we could create like a fake store for testing that just keeps a list of like all of the actions that had been sent to it. And then what we could do is run an assertion on that store. What's the word? Run an assertion on that store to make sure that that action was processed. So can we do that? So I'm wondering if I made store I'm wondering if I want to subclass store or maybe so I'm going to do something a little taboo just to be able to write the test and demonstrate it. Which is that I'm going to make a public val and put like action history and make this a list of actions. This will be a mutable list. So something like this shouldn't be used in a production project, but it's used for easily demonstrating unit tests where we want to ensure that an action has been dispatched to this store at some point. Ideally, store could be an interface that we mock for tests. How about using a middleware for this? A test middleware. Huh. That's a really good idea. That's a really good idea. Let's do that. Let's go into our... That's a really good idea. Let's create we'll call this what do we want to call this? Action capture middleware. I don't know. I might need to... I might have a similar error here later, but let's just go with it for now. So this is a implementation of middleware that will log every action sent to it, so we can use this in a unit test to ensure, in a unit test, we can apply this middleware to a store and then use this middleware for asserting that an action was sent to that store. Okay, so then here we can have, we can even actually make this private here. This is going to be a mutable list. And then we can do something here. We can do like assert action processed, so we can have like an expected action. And then we can do assert that action history that contains expected. I want to call this expected action. I think in a second I'm going to have some generic issues again, but let's go with this for now. So in processed, we'll just do action history add action. I like this. I think that documentation clears up what this does. So yeah, so then in our login networking middleware test, we can go a little step further and we can say, you know, our store will be store. We can call this input state login reducer. We'll call this login store. Yeah, that's what I'm thinking of. I'm gonna try this for now just to see if it yells at me. And then we call this action capture middleware. Yep, this is where it's yelling at me. Also, this is suspending, so we'll have to do another stuff. Okay. I wish... I don't want to make action capture middleware like I don't want to make this so it would be a test middleware. Honestly, yeah, I didn't really want to do that. Because then this can't be whoops. Because then this can't really be like reused, but that could be a problem for another day. Oh, you're right. We did this before. This is what we talked about doing. I need to genericize this. We talked about doing this earlier. Yep. I remember. So we made this generic. So inside the middleware test, oh, right, we can actually leave it out because type inference, because Colin is amazing. Okay, so, and then we can pass in login store. and then we can run our assert. So here we can do, actually we should, so we can track that action capture middleware. Whoops, well now that I've put it out, I need to do it. But that's fine. So we'll put action capture middleware. And then we can process and we can say, so we can say we want to assert action process. Specifically, we want invalid email submitted. Okay, so let's talk about this test one more time. I'll fix this warning in a second. So we have a lot of givens that go into this. We have our fake repository. We have our input state and action. We have the middleware under test. Let's rename that middleware under test. And then we have our action capture middleware. And this is our test middleware to make sure that an action was dispatched into a store. We create that login store with that input state, just a default reducer, and specifically the middleware we want. So then we take our middleware, we tell our middleware to process with these inputs, and then we will claim that this test passed if our action capture middleware received the item it wanted. So now this is yelling at me because this needs to be in a coroutine. What you can do inside a test, there is a coroutine test library where you can implement something called a run blocking test, but rather than look it up, I can just put run blocking right here and then post this in here. This calls, I think, on like global scope and just runs like, it just creates like a blocking coroutine. You should never use this in your production code. Totally fine in tests. So let's run this and let's see if it passes. It passed. Great. So we could do a similar thing with like valid inputs real quick. Let's do that real quick. I'm going to copy this test because a lot of it's going to be the same. Let's document it real quick. So when running this test, we want to ensure that after having LoginNetworking middleware process the sign in button clicked. Oops, I guess it's not even there. Action, when the email is invalid, it should then have the store process the invalid submitted action. Just to clarify. So let's copy this. Let's run this. Let's call it valid login. So this test is going to be when the LoginNetworking middleware processes the sign in button clicked action and there are valid inputs. We want to ensure that the corresponding actions are sent back into the store. Okay, so that's what we're going to do. We can leave the same fake login repository should mock success is true. Let's give this real data in our input state. So our input state can have that email, password, everyone knows this, hunter2, same input action, same process, but now our assertions will be a little different. So we're actually going to test for like a few things here. So we want to assert that we sent login started, and we also want to assert that we did login completed. Because further up here we set should mock success to true, then we expect this will fire with login completed. So with that note, actually, let's copy this again and let's do a failure test where we set should mock success as false, and then down here instead of login completed we're going to set the test to return login failed, or to expect that it triggered login failed. So we'll do login failure, should mark success here as false, and then down here we do login failed with no error. I should actually just take this out because we didn't end up using it in the project. Let's run these tests. And they all pass. Awesome. I've never written so many passing unit tests in one time like this. Finally an Android dev stream. Yeah, I'm glad that you're here. We stream every Wednesday. Thanks for coming by. You're just at the tail end of it, but we still got doing a couple more unit tests. Super exciting. So what was the last test? Oh, the idea of testing like our store class itself. And this one actually gets a little trickier conceptually from like testing practices. So let's look at our store class real quick. So when thank you for the follow. Is it Sheldo Ryan? Hope so. So before I started down the rabbit hole of writing tests, we were able to write a test specific to our login reducer. We were able to write a test specific to like a login middleware. When it comes to unit testing our store though, this store is actually not specific at all to anything related to login. So if we wanted to unit test this, we could supply like our own implementations of this stuff, and maybe write a unit test that ensures that like it processes each middleware, and then that it gives a new state to the reducer, and gets a new state. So let's kind of write that test. Let's simplify that. Let's write a store test class. And so I'm going to write this test independent of any of the login stuff that we already talked about. So I'm actually going to rewrite some of the classes that we dealt with real quick. So let's create like a test state class, and let's have a boolean here like is completed, like for is test completed, and we'll default this to false. We can have like a default action, which is like run test, something like that. So we can have like object run test, and this will just be an action. And then we can make like a test reducer that deals with these two things. So let's make like a test reducer, which will be reducer for state action. And then what we can do is we could have it be like, well, we'll do the same thing, return when action. We'll say if this is run test, we're going to return this state.copy. Whoops. Let's actually have this be test state. And then we could say is completed equals true. And then otherwise, we're just going to return the current state. So I'm going to add some notes. Please see notes in login reducer and reducer in app directory for real documentation. Yeah, so this is some test inputs, and let's not test the middleware right now. Let's just test we can create a test, and we could say store processes action through reducer. So we just want to test that we can create a store, have it dispatch an action, and make sure that goes through the reducer. So let's just put dispatch sends action to reducer. And actually, I guess this font looks good. Thanks. It's actually just the default font. I'm trying to think. I'm getting a little ahead of myself on this test because I don't really want to test. If I'm testing my store, I don't really want to test like that the reducer does something. I just want to test that like an action was processed. I guess I have the same thing as before. So maybe what I should do is instead of reduce, we can keep this as, let's keep this as a regular state. We can do a similar thing here and keep an action history, which will be mutable list of actions. And then every time reduce is called, what we can do is we can just say action history.add the action and then have it return current state just to satisfy the compiler. And then have a function assert action processed, and we can say expected action, and then we can say assert that action history that contains expected action. Okay, so this is really what our test reducer should do, is it should just record the base information needed for our test cases. So when we want to test up here, we want to say dispatch sends action to reducer. We can say, input state will be, we can even call it a test state. Let's really make this, let's call it test state and test action, just so we have them for compiler's sake. So we have our input state, we have an input action. So from here we can create our store, which will be a store with the input state and input action. Why are you yelling at me? Oh, because this is actually test reducer, so it should go here. And then so what we can do, so these are the given, and then we can say when store.dispatch input action, and then we can say we want to do, let's pull this out. We want to do reducer.assert action processed input action, and wrap this in a run blocking. Sorry, let me just write up and then I'll go through it again. So to unit test our store, we have some given inputs, our input state, action, reducer. We create our store. We have our store dispatch an action, and then we want to make an assertion that the reducer handle that action. So let's run this and let's make sure it works. And if it does, we can do a similar thing with like the action middleware. We can create a store that uses the action capture middleware. Maybe that's what I should have called this. I should have called this like action capture reducer or something. Oh, but that test passed. I closed this. But it's somewhere in here. Yeah, that did pass. So we can do a similar thing. Let's change this. Dispatch sends action to reducer and middlewares. So we can create a middleware, which is action capture middleware that we made earlier. Make this use the defaults. We can pass that into our store. And then the same place where we make the assertion on the reducer, we can say middleware.assert action processed input action. And let's run that. And that's just a way to assert that our store passes things to both items. And it still passes. Awesome. So I'm going to commit this, and think. Let me know if you have any questions on anything we did. I will sit. Oops, I am always happy to sit here for as long as people want to ask questions, either about the stream or any sort of Android or GDE AMA stuff. But I am at the point where I'm done writing code. I will sit around. I promise. I will sit around and chat as long as people want. But I'm gonna call it quits on code for there. So let me know if you have any questions on stuff we did. Thanks, Matt. I really appreciate that. I hope MVI was interesting. I will make sure that I take our flowchart of everything that we built, and I'll make sure this gets added to the README. I will also, I'll try to put some more documentation in the README. I haven't done that in the last couple weeks, but I'll try to do that with this one, because this one was a lot. And when I put it on YouTube, I'll use video markers to make it... I'm just going to do a lot to try and make this really... thank you for the follow, JLexDev. I promise I'll do everything I can to make this one more digestible, because this was... It's not my longest stream yet, but it's definitely up there. We went through a lot. Huge thanks to all of you who hung out for it. I really appreciate it. Y'all are the ones who keep me going every week. So, yeah. I didn't do my short recap of the store test, but just to do that again, you know, instead of having this test any specific state or action like we did with the login stuff, we're just using some sort of stub state and action and verifying that our store dispatches an action to the right places. If we wanted to get really fancy, we could implement some mechanism to make sure that it dispatches in like a particular order, but we'll leave that out. Yeah, thank you, Adelisto. I appreciate it. Definitely, if you do have questions rewatching it, the easiest way to reach me is Twitter. Either publicly or through direct message. But yeah. Or feel free to, because this is on GitHub, let me drop that in there real quick. Yes, it will be uploaded to YouTube. I probably won't get to it right away. I think even Twitch makes me wait or I'm supposed to wait 24 hours, but I will try to get it up there. But this project will also be on GitHub, so I mean, if you have thoughts or questions, you can also submit issues there. Whatever is the easiest way to ask your questions, I appreciate it. And as a last plug, if you are active on Twitter and you do follow me there, I still need to make a Twitter. Command. I actually don't have that yet. But let me drop my profile in here, because we are active on Twitter. One of the things that I really I'm always looking for stream ideas of things to work on. Oh right, you found this for the first time. What do you think about Jetpack Compose? So that's funny. Tonight is the first night in 2 months that I'm not streaming about Jetpack Compose. That's been my big thing for quite a while. I will drop a link to... I need to get a good channel name. But I can drop a link to my YouTube channel. Some of our previous streams have been posted already that deal with Jetpack Compose. So we did one of the Android Dev Challenge apps, Bloom. We built that whole thing in Jetpack Compose. I did a similar stream to this one where I explored the MVVM architecture and building that into a Jetpack Compose app. And then 2 weeks ago we did building a staggered grid in Compose. That was a lot of fun. No, it was a great question. I'm sure we'll go back to doing some more Compose stuff. I love it. I can't wait for it to be stable in July. I actually talked to my teammate at work, and we're already interested in just jumping on board now. I'm working on a project right now that I'm going to try to build a few of the fragments in using Compose. So I'm excited. I think it's a really great framework. Thank you for stopping by. I appreciate it. We're here around this time every Wednesday. I keep saying one day I'll pick up more slots, but until then, every Wednesday you can find us here. So I am going to save this before I forget. and see if I can figure out how do I export. Nice. Already exported. No, it's fine. Don't worry if you re-ask questions. I'm always happy to revisit anything. What would you prefer, MVI or MVVM? In case you choose one, why? So I kind of hinted at this throughout. In a lot of scenarios, I would just say model view view model. And what that really boils down to for me is just the learning curve is a lot smaller. There was a lot going on here, like a lot of files, a lot of boilerplate setup. I think once you understand it, like anything, once you understand it, it moves a little faster. But for just dealing with an app that had a login screen that had 2 inputs and a button, we added so much code. And we got a lot out of it. We got really good, clear, and predictable state management. But I think in a lot of screens, it's not that necessary. So I think it's hard. I'm trying not to give you an it depends kind of answer, but it does. And I think I would base your decision, kind of ask yourself, like, how important is that clear and predictable state management to you? If you have a screen that has like a lot of inputs and a lot of moving pieces and sort of a lot of things that can manipulate your view state, I think that it can be really helpful and really powerful. If you are building a screen that is really just standard, fetch some data and display a list of items, then MVI might not be necessary. So that's my 2 cents. And I think, maybe in my experience, a lot of apps I build follow that other pattern. I'm building a lot of screens that just have some recycler views. So I just use MVVM for a lot of stuff. Even if a screen is a little more complicated, then I just keep the model view view model set up. But maybe a controversial take is you don't always have to pick one and only use one in your project. I think consistency is important and I recommend it, but you can also ask yourself, like, if one particular screen is worth it. So for an example, at my last company, I worked for a company called OkCupid, and we built all of our screens using model view view model. But then I was tasked with the role of building the your profile screen, where you can update your pictures, you can fill out essays related to yourself, you can answer questions, you can add like your social media integrations. There were all of these different moving parts. And I said, I know this breaks with our typical architecture, but I think we should go with a Redux flow for this screen because the screen is complicated and warrants it. And my team said, okay, we're going to sort of break consistency for this screen because it's the right tool. So that's something to keep in mind. That's an option if it comes down to it. I hope that answers the question. I try not to... A lot of these questions, my instinct is to say it depends, but what I really like to do is like, it depends on what, right? And I think the what is how complicated is your screen and do you really need that state management? And if the answer is yes, I would go with something like this. But if you really think about it, you might find that answer is not always yes, even if it sounds like the right thing to do. Yeah, glad.